The next study design that I want to discuss is the case study. Case studies are what we call retrospective studies, which means that they look back. Basic design is very simple. On the one hand, you recruit a group of patients with a certain disease representing the cases, and on the other hand, you recruit a group of subjects that do not have the disease, the controls. And all the subjects are asked about their past dietary habits using food frequency questionnaire or another type of dietary assessment tool. Next, the dietary information from the two groups is compared to see if between the groups there are any differences in intake of certain nutrients or an intake of certain types of foods. Now let's look at an example. Imagine that we are interested in the link between diet and colon cancer. A group of colon cancer patients is assembled together with a control group of non-patients of about equal size. Let's say about 300 to 400 people. And as I just explained, information about the participants' dietary habits is collected using a food frequency questionnaire and compared between the two groups. A possible finding could be that colon cancer patients report a higher consumption of meat than the controls, and if the chance that the observed outcome is due to random, chance is very less. Then we can say that meat consumption is associated with elevated risk of colon cancer. A major advantage of case studies is that they allow you to study the link between diet and rare disease such as certain forms of cancer, and cohort studies are less suitable for that purpose unless they include hundreds of thousands of individuals. The weakness of case control studies is that they are prone to different types of bias, and I will try to explain that in a little more detail. The most common one is selection bias. And now imagine that the colon cancer patients are recruited from one hospital in a poor part of town, whereas the controls are recruited from a private clinic, and obviously the dietary habits of the two groups will be quite different without having anything to do with colon cancer. Now another source of bias is called recall bias. Now recall bias happens when there are systematic differences between the cases and controls in the way they remember or report their dietary intake. It's well known that people that are affected by a disease have a different recollection of the past than people that are healthy. And therefore, to minimize recall bias, it is best to use a control group that has a different disease which is unrelated to the disease being studied. Putting these together, we can conclude that in order to avoid these biases, it's best to find the control subjects in the same hospital as the cases and make sure they have a similar social background. A case control study can also be the victim of something we call confounding. Let's return to the above example where we found that colon cancer patients report a higher meat intake compared to the controls. Imagine that a higher meat intake is coupled to obesity, which is a known risk factor for colon cancer. Eating meat by itself may not be a risk factor for colon cancer, but because the meat eaters are generally heavier, a positive association is found between eating meat and colon cancer. And in this example, obesity is a confounder, and in the study, any known risk factor for colon cancer can be a potential confounder of the relationship between meat intake and colon cancer. What researchers do is to apply computational tools to limit the influence of confounding as much as possible, which we call adjustment for confounding. However, some confounding always remains. For this particular example, It's tempting to conclude that the higher meat intake in colon cancer patients suggests that meat consumption causes colon cancer. However, because of the inherent limitations of observational studies, the only conclusion that can be reached is that a higher meat intake is associated with or is correlated with a higher risk of colon cancer. Now, carefully keep this in mind whenever journalists or researchers or students make any causal inference between diet and disease based on an observational study, they are overinterpreting the data. Thank you.